Okay, so this is going to be a very quick rundown of all that your project does and how to use your project. Don't worry, there isn't going to be any connection video because one, there is no time, and two, I've already connected everything appropriately. So try your best to keep the connections the exact way I kept them, because if you misplace the connections, it's going to be tough putting them back. So I've connected everything right already. So first, let's identify your nodes. This over here is your sync node. This is what your sync node looks like. That is the XB module on the sync node. This is the microcontroller, the LCD display, and this is the power supply that will power your sync node. If you look at it, it's a 12 volts plug at 1 amp, and it's connected like this. So I've already made the connection, although it's detachable. I've already made the connection and I've made it correctly already. Just match the colors in case it's misplaced. So that's your sync node. Next, this is the power supply that will power the rest of the circuit. It's a big 4 amp 12 volts power supply. It can deliver up to 50 watts, so it's a very powerful power supply. It's kind of overkill even, but only the best for the best projects now. Still on your notes, over to this side here, you see I have to adjust the camera a bit. Okay, you see that is node 1 right now. What you're looking at is node 1, and node 1 measures temperature and humidity. And when it measures temperature and humidity, it controls the infrared bulb, or in this case this ordinary bulb, and it controls the fan. So now on it there are 2 switches. We're already into the video. On it there are 2 switches. You can see this one and this one. Those switches are manual override switches, and they allow you to control the control the apparatus, which is the bulb and the fan, how you want. So you turn the switch up, it turns on the bulb. This is for the bulb, this is for the fan. You put it in the middle, it allows Arduino to take control of the pump of the bulb, and then put it down, it turns off the bulb whether Arduino wants it on or off. Just leave it in the middle, except you want to turn it on yourself. So the bulb is controlled based on the temperature. If the temperature drops below 24 degrees centigrade, the bulb will come on, and it will remain on until the temperature rises above 35, I believe, 35 degrees centigrade, yes. Then it will go off, and when it goes off, it will turn on the fan. You understand? So I put those switches there because it's very unlikely that the temperature will vary like that while testing in real life. So those switches are there for you to be able to control them. Now, if you want the bulb to work, you can see the bulb is connected. The bulb is connected to the circuit board via this wire, but that's not the only connection required. You still need to plug in the 220 volts that will power the bulb through this port here. Now I'll send it to the port. So this is the port we're looking for. This ordinary rechargeable amp port. I will send it with it. Just plug it in here and plug it to power, and now your bulb can come on and come off. Ordinarily it can't. Although I would just say 220 volts is very, very dangerous. It can kill you if you touch it, and since this is a Vero board soldered with a lot of other components on board, be careful when plugging in 220 volts. Make sure the bottom of the board is clear and is on an insulator. And I would even say don't even plug it in. don't let 220 volts in. But if you must, you can. You understand? But personally, I wouldn't, except as a last resort. You really want to demonstrate it, you can. It's fine. But for safety reasons, don't. So here is the humidity and temperature sensor we're using. This blue thing over here, that's the humidity and temperature sensor. This is the air quality sensor. Remember, we couldn't get an ammonia gas sensor, so we're using an ordinary MQ2 sensor like the other one. This is the XB module. The XB module is detachable. Okay, I use header pins to set it up. So the XB module is completely detachable, and this is the adapter, and you can also remove the XB from the adapter, so everything is still intact the way it was given to me. Yeah. So just make sure you put it in the right way, if not you will damage the board. Yes, if you don't put the XB module the right way, you'll damage the board, the entire board. It won't just, not that it won't work, but you allow 5 volts flow into where 5 volts is not supposed to flow into, and you can cause serious issues. So trust me when I say it has already spoiled something for me. Be careful. So just align them properly. In fact, if possible, don't remove the XB modules at all. But if you must, let me show you how to put them back. One, if you notice, all the XB modules are always facing towards the microcontroller, and I don't even want to start showing you how to unplug it and plug it back, but the only pin that doesn't get connected really is the reset pin. You can't see it. I don't know why this camera can't just focus properly. Yes, the reset pin is the pin that is currently at the extreme right. So in node 1 there is a port for reset pin, but it is never used. But in the other nodes there is no port for the reset pin. Do you know what? Just don't remove the XB module. I've put it in the right way. Don't remove it. Put it back. Okay, so that's your node 1. This other switch is controlled the same way the first switch is controlled, but it's used to control the fan. The fan is also controlled by the air quality sensor, but chances are that you wouldn't have such dusty and smoky air that it would turn it on. So that's why I put the switch there, so you can control it yourself. Okay, now that's about what node 1 does. The humidity sensor measures temperature and humidity, and then it transmits its data using the XB module. That's it. Now on to node 2. For me, the most exciting node because it's what measures food and water quantity, and it uses weights to do it. So already you can see a bunch of jumping wires about. Now the first thing you observe about node 2 is node 2 is connected to node 1 using this wire. This wire contains 12 volts and 5 volts ground for each of the terminals. So there are just 2 power supplies, one that is connected to node 1, and that same power supply transfers power into node 2 using this wire. Try and keep the wire the exact same way it is, but if you must unplug it, make sure you plug it back. Just match the colors of the wires. See, it's completely detachable, but just match the colors and be careful when putting it back. So always keep that wire connected. That's the wire I mentioned to you. Apart from that, it also contains a backyard protocol that always prevents one node from interrupting the other node when talking to the sync node. So it's very important. So basically node 2 controls this or receives input from this. So let me bring it closer to the camera. This is a digital scale which I built. Yes, I know it looks awesome. But this is a digital scale, and it's what they call a 1 kg load cell. If it focuses, you see that there is a 1 kg boldly written on it here. So basically what this scale can do, it can measure any weight between 0 and 1 kg. Any weights higher than 1 kg can permanently damage the scale, so be careful. Don't place heavy weight on it. Apply gentle weight on it, if not it might damage the scale permanently. That's 1 kg might surpass the elastic limit. So the way this scale works, just Google the scale. Just search for 1 kg load cell. You see it. I don't want to load this video with how it works, but in summary, just Google the scale. Just Google it and search for it. So yeah, I use a Veryboard as its platform, and all you need to do is place this on a flat surface and then put the object here and to measure it accurately. Now it's measuring it in grams, but it's not going to return the value in grams. It has been calibrated with a standard value so that it can measure the weight not in grams but in percentage of that standard value. So for example, this, I couldn't get Gary. I know Gary was what we're going to use as the grain, but this is semo, so we couldn't get Gary. So this is semo, and we're using this as the standard substance, let me put it that way, as standard grain. Now if you put the plate of semo on top of this plate, for example, it will measure the weight of the plate of semo and to know the quantity of semo that is inside the plate based on the weight. So as the chickens are eating the semo, in this case now, it could be any grain, but as chickens are eating them, it will be detecting the reduction in the weight. And so once the reduction, once the weight or the quantity of food has reduced beneath 25% of the standard, which is the maximum quantity of semo you can carry, it will turn this servo motor. Now the reason why I made it a servo motor is the servo motor is to represent the action of opening a nozzle or opening a space for grains to pour back into the plate so that the system can support itself. So we couldn't set up such an elaborate system that will actually have the grain pour back into the plate. But the servo motor's job now is to open the nozzle that will let grain pour back into the plate. So that's what the servo motor does. Now, on the other hand, there's another empty bowl here, and it's for water, and we place it on the other one. If the water is finishing, the same process takes place. Only difference is there is a solenoid valve here. Now the solenoid valve is basically an electronic tap. If you connect one end to a tap using a hose, which I'll send in case you want to, and the other end into the bowl, it will block the tap from letting water into the bowl. But the moment the bowl is getting empty, it will open the valve so that water can flow into the bowl until the bowl is full. And once the bowl is full, to stop letting water in. So that's how it works. And at the same time, it will be returning the quantity of food and water via the XB module to the sync node. And now we're back to the sync node. Now the sync node, this is it. The sync node will just display the temperature, humidity, the quantity of food and quantity of water that it's receiving wirelessly. Now, unfortunately, I was not able to connect it to the internet, so there is no IoT feature here. But had it been the connection, this is even the space where the Wi-Fi module was supposed to go in, but couldn't work. I'll still include the Wi-Fi module in the packaging. So when it receives all this data, it would keep updating its values, the values stored on the module, so that it can be sent via over the internet if you want it to, or however you want, whatever you want to do with data. But now it also serves as a notifier for bad values. For example, if the water level is low, it would Node 2 is supposed to automatically adjust the water in the bowl, but it will notify the farmer immediately using the buzzer and the LED indicator that something is wrong. Once it starts buzzing and the LED indicator is flashing a red light every time you update the display, just look at the readings. It means something is off with the readings. Next, if the network is disconnected, or the network exceeds its maximum range, the connection between the sync node and the sensor nodes, the sync node will make a loud, it will basically let you know that it can't see any of the nodes. But if the sync node can see just one node, it will focus on that one node. It will keep receiving data from that one node. So at the moment, I couldn't make the network robust enough for it to be able to detect if any node is missing or faulty, but it can detect when no node is talking to it. So let's just quickly put it on and see what it looks like. Now, to put it on, first connect the sync node. It's the coordinator, so it's supposed to be put on first. But this is the power plug. This is it. Okay, just plug into the socket. I'll plug into the socket here. Okay, and if you observe, it is on at the moment. Hold on. So this is what it looks like when it's turned on. Once it's done loading, it'll begin doing its job. So at the moment, only the sync node is on. Okay, only the sync node is on. So you hear the buzzing, network error. It can't see any other nodes. You see this going on. So yeah, this is what the sync node will do if it doesn't see any other node at all. It will keep doing this over and over until it finally catches a node. Okay, so the sync node is on and it's already making noise about no network because the other nodes are not connected yet. So I'm about to power on the other nodes. Let me simply set up the power supply. Okay, to power the nodes, all you need to do is, you see this plug, this very plug here. Yeah, it's still making noise about the other nodes are not on. So you see this plug, you're just to plug it in to node 1. See over there, right over here, just plug it into node 1. So that's what I'm going to do now. When you plug it in, then plug it into a socket. Okay. Okay, now it's plugged into a socket. We're going to power it on now. There's a switch here. Just press the switch on. So if you notice, okay, this is the startup sequence. If you notice, the my sync node is making a different beep altogether. And this is your node 2. So can you see the green and red alternating LEDs? Each when it's green, this is where the transmission protocol on how exactly the nodes communicate with the sync node. The transmission protocol is set up such that only one node can talk to the sync node at a time. While it's talking to the sync node, you see the green LED will come on, and it will set a particular pin that will tell the other node that it is talking, so the other node should basically shut the hell up. Now, when this happens, it will show the red light that the other one is talking. Now, when the first one is done talking, it will now set its light to red and tell the other one it can now talk. So that's why they keep alternating that way. Okay, so that's basically how it works. Now let's turn over to the sync node to see what the sync node is saying. Now on the sync node, if you can see, it's displaying the humidity, the temperature, the food and water. So food is saying 81%, that is the bowl full of food is 81% full. Water is saying 2%. Well, that's just the weight of the plate itself. And luckily I'm using this ordinary takeaway pack, so you can just buy your own takeaway pack and use. So let's fill up the water jar, the water bowl, and see what its new measurements will be. Hold up, let me adjust this camera. Okay, so this is it. Okay, so I'm pouring water into the water bowl now. Let me pour it to about half full and then see what it says the water level is. So looking at it, the water level is still showing as 2%, so let's wait for it to update. Okay, so now it's 68%. 68% now. Humidity is 66, temperature is 62. Okay, now if you notice the buzzing, the buzzer has stopped buzzing. That's because food and water are now, there's now food and water. Do you understand? Now let me show you the way the LED indicator is. Every time it flashes this cool colored LED, the blue green LED, it is indicating that it just received data from somewhere. Every time it receives data, it flashes the LED. Okay, but then if you see a red flash in it, it means something is wrong with that data it just received. So for example, let me take out the plate of grain altogether and you observe something. For now, it hasn't updated yet. Okay, but once the food updates, you will see something. Yeah, it takes a while to update because each node talks separately. So you see food is now 0. The buzzing has started again. There's a red flash attached to each blink now. So you understand? That's how that one works. Let me place it back. And once food updates, you would see that, yep, food has updated. So the red flash is gone, the buzzing. Okay, I just realized one last thing I didn't test out. I didn't test out the bulb. I didn't test out the fan for it to see. So I've plugged in the bulb now, using this plug here. First, I'm going to show you the fan. Now this is the switch for the fan. If you turn it up, you can see the fan comes on. Normally the controller is supposed to control the fan, but only when the temperature is 35 degrees or only when temperature is 35 degrees or there's excessive smoke and dust in the air. And so because of the unlikelihood of that happening during your defense, I left the switch there so you can control the fan, so the fans work, as you can see. Now same goes with the Note 2. The solenoid valve can be controlled using this as well. So if you take a look at this, see, you can wow, this stuff is really warm. Okay, so listen to that. It can be controlled using this as well. Okay, now for the bulb, fingers crossed. If you plug in the bulb, okay, I've plugged the bulb in right now. The bulb is plugged in, then you control this switch. You see the bulb comes on. Okay, demonstrating that the bulb is working fine. So the mic controller, just the same way I controlled it with this switch, can control the bulbs as well. Just be careful when plugging to 20 volts in. You could really hurt yourself.